All right, so for the system of equations, I'm going to start with problem number 2. Of the 2, it requires the lesser amount of work. So in doing a substitution problem involving a slope-intercept and a general equation, we're going to write down the general form first. It's a good idea if you need to rewrite it, make sure the x and y are on the same side. And then what we're going to do is we're going to replace the y with what it equals. So the problem becomes 4x plus 2 times x minus 13 equals 10. And then all we're going to do from here is solve for x. So we do the parentheses first. So 4x is equal to, 4x plus 2 times x, 2x. 2 times 13 is negative 26, or minus 26 in this case, equals 10. Combine like terms, so we have 2x and 4x. So we're at 6x minus 26 equals 10. Now we're at a place now we can solve the equation. So add 26 to both sides. 6x equals 36. And then divide both sides by 6. So x is 6. From here, we know the two lines intersect at 6 comma something, so we have half the solution. So now we need the y value. So to find the y value, we choose one of the equations. I would suggest choosing what you see as the easier of the two. I think the linear is always going to be probably easier than in slope-intercept than in general. We replace the x with 6. And so y has an answer of negative 7. So these two lines, graphs, are going to intersect at 6, negative 7. For the second one, what we have to get is, or the objective here, or the goal is we have to get opposites. So that would be opposites for either x or y. So right now we don't have opposites. So if I'm looking at the x's, the number is, I'm just going to ignore the negative sign. So the two numbers are 6 and 8. And if I start counting off by 6s and 8s, what I'm looking for is that first numbers that they both share, which is called least common multiple. And one way of doing it, if you don't know the answer, is list both numbers. And I'm looking for that first number. So if I wanted to get rid of the x's, I would need to make one of the terms a 24x and another term a negative 24x, so that when I add them together, I get a 0. Now if I want to get rid of the y's, I'm starting with a 10 and a 5, and if I start counting off by these two numbers, the first number they share is 10. So if I wanted to get rid of the y's, I would make one of them a 10 and the other one a negative 10. So since I already have the negative 10, it would probably be easier to rewrite the second equation only, make it into a positive 10, instead of having to rewrite both equations, which is what I would have to do if I want to get rid of the x's, since neither of the equations have 24 in it for x. So first equation, we're going to leave alone. Second equation, we're going to take 6x plus 5y equals 2. We're going to multiply that by something, kind of like we did with the decimals activity. And so we're going to do, so this one's going to stay negative 10y. So we're going to make the other one positive 10y. And so to get this to be a positive 10y, we need to multiply the 5y by 2. So 5 times 2 gives me 10. And then I will multiply the other terms also by 2. So I'm going to have a 12x and a 4. So we're going to add these two equations. And by doing so, it eliminates the y altogether. So 12x, take away 8x, is 4x, equals 28. Divide both sides by 4, and x is 7. find the y value, which is another part of the solution here, we need to choose one of the equations. I would probably choose the second one since everything is positive. So we're going to replace x with the number 7. It's off the y. So 6 times 7 is 42. Subtract 42 from both sides. 5y will equal negative 40. And then divide by 5, and y ends up being 8. So the solution, and this is where the two graphs are going to meet. So the two lines are going to meet at 7, negative 8. And that will be our solution. And for the third and final problem, we are trying to rewrite this equation so that we don't have fractions. So we did this in the last class. So what we're trying to do is multiply something on all three terms, but multiply by something that's going to get rid of the denominator. So if I look at the 9 and the 18, kind of like the system of equation in the previous screen, I'm looking for that first number. If I start listing multiples that both 9 and 18 share, which is 18. So I'm going to get rid of the denominator, I'm going to multiply all three things, all three terms, by an 18. So 18 divided by 18, that's going to be a 1. 18 divided by 9 is 2. So we've got a factor 2 left over in the second term. And then 18 times negative 1 is going to be negative 1 times 18. So there's no fraction here, so we're getting rid of here. So the first one, we got 7x. In the second term, we have a 10y. So it's 5 times 2 is the 10. And then the third term, we have a negative 18. So these two equations, 7/18 x plus 5/9 y equals negative 1, and 7x plus 10y equals negative 18, both these equations will create the same line. It's just now we don't have to deal with the fractions.